Okay, so this is our first example of the problems involving equation of motion under rectangular coordinates as inertial reference frame. So the problem reads, the motor winds in the cable with a constant acceleration such that the 20 kilogram crate moves a distance of 6 meters in 3 seconds, which starts from rest. The question is, what is the tension that is developed in the cable? Another given is the coefficient of kinetic friction between the crate and the plane is 0.3. So first things first, summarize all given. First is it travels a distance of 6 meters. 6 meters in just 3 seconds. The mass is 20 kilogram and it starts from rest, meaning the initial velocity is 0, and of course the mu k is 0.3. So for the required, the tension, what is the tension? Okay, for the solution. So for the given, we still have FBD. So I'll just write the FBD here in the space diagram. So first we have the weight, which is 20 kilogram. The weight, this is the Y component. This is the X component. Let's assume that our inertial frame of reference is this XY. This is the positive, and this is the positive X and the positive Y. So these are the components of the weight. Of course, we have a normal force in reaction to the WY. Of course, we have the tension that is developed on the cable. And since we have given a coefficient of kinetic friction, then there is a kinetic friction force. But the sense or the direction of that friction force, it must be opposite to the direction of motion. So the motor winds in. It means that it is going upward. So the motion is uphill or up the incline. Therefore, the Fk is in this direction. Okay, so I think we have already accounted for all forces that act on the crate. The components of the weight, the normal force, the tension, and the friction force. So now we're ready to formulate the equation of motion. So we have two axes, the X and the Y component. So personally, I go first with the equation of motion on the Y direction because it is easy. And another thing is that it gives me idea about the normal force that will be used on the another equation of motion along x-axis. So this is just a personal strategy. First, let's go for the summation of f y. That will be 0 because there is no motion along the y-axis. So it is in static equilibrium. So we have n and wy. So you can choose to write like this: positive n, negative omega y, wy equals 0. It's up to you. That's still okay, but for me, I just write n equals to wy because it is just statically equilibrium. There is no need for pedantry. Okay, so next is for the x, for the forces along the x. So here we have the sum of all forces along x. This is not equals to 0 because there is motion along the x. So it is max. This is in dynamic state. Here, since the right part of the equation is positive ma, then personally also I try to make sure that the result on the left side of the equation is positive, meaning in this case the motion is up the incline. It means that all the forces that act on this direction are greater than all the forces that act in opposite direction. So even though the motion or is down the incline, for instance, of course the motion, the forces, all the forces under that act in this direction are greater than all the forces that act in this direction, and it is negative, I still write all the forces as positive because I'm considering the absolute concept of this equation, because you have to expect that the right part is positive term. Therefore, you have also to comply with that on the left side of the equation, irrespective of the signs of the direction or the conventions of the directions. So I just treat it as that. You can also follow that strategy. So all the forces are greater on the right. So those are actually it's just tension. It's just tension that is in that direction. So tension minus all the forces that oppose to the tension are minus Fk and also minus Wx is equals to max. So T is greater than both Fk and Wx, because if it were not, the crate would not move upward. So the result of this is positive in compliance with the positive term on the right side of the equation. Okay, so we have T minus Fk minus Wx is equals to max. Alright, so T, this is the required, so that would be max plus Fk plus Wx, and max plus mu k. We know that mu k is Fk, sorry, mu k times n. So n here we have Wy from here. So again, we write mu k n or Wy plus Wx. So here we know, or we have an equation for tension, which is a function of the acceleration a, because all the terms, the mass, the mu k, the Wy, Wx are givens, except for the ax, which can be solved using kinematic properties or the kinematic equation, because it says here that the acceleration is constant, meaning it belongs to category 2. Okay, so we need acceleration to complete the value of tension. So how are we going to find that? Given the distance, the time, and it starts from rest, we can use this equation. S is equals to v0t plus minus 1/2 at squared. It starts from rest, so it's 0. The distance is 6 meters, and let's assume a positive equation, positive acceleration, and the time it takes for 6 meters is 3 seconds. So 12 divided by 9 is the acceleration, or 3/4 meter per second squared. So we have acceleration. So we can solve for now for the tension. Okay, so finally plugging all the givens. M is 20 kilogram, 4/3 meter per second squared. Uk is 0.3, and Wy, that would be cosine. Weight is 20 G. That would be 20 G for the gravity, times the cosine 30, plus the 20 G again, that's for the W, and the component along X is sine 30. Correct? So the total value of tension is 175.74 Newton. So that's the answer.